All right, students, for this last video, we're going to start out by determining the missing information. What piece of information would you need to say these triangles are congruent by? So this first one, we're saying HL. So we already have the right triangles. Nice. Next, we have this shared side, which is congruent by reflexive property, which is actually the hypotenuse. All right, and there's actually, you could use a couple different things. We could say AC and ABD. That's legit. Those are legs. Or you could say AB and CD, but we only needed one piece, and those are legs. So that would give us a triangles congruent by HL. All right, this next one. Yes, these are right triangles, but you don't always have to use HL when you see right triangles. You can still use other things such as side angle side. All right, in this particular case, we have a side, we have an angle, so I need another side. All right, and the side I pick has to make the angle included. So this would be a side, and this would be the side. So it'd be SU congruent to FH. All right, next one. Angle, angle, side. All right, so I have an angle, I have a side. This time the angle has to make it non-included. It can't make it this where the side is between both angles. So boom, G, and boom, Q. Angle G is congruent to angle, or did I say Q? I meant to say P. Oops. And anyways, last one, angle, side, angle. All right. So now we need the angle to force the side to be included. So it's going to be angle F and angle Q. Nice. All right, now we got some proofs, and then we're done. 2 proofs, and then we're done. Bada bing, bada boom. All right, given that sides are parallel and some sides are congruent, so AD is parallel to BC, and they're congruent given. All right, furthermore, how do I know that angle 3 is congruent to angle 2? Well, remember, when we have parallel lines, a lot of times we're just using alternate interior angles because the shared sides are transversal and then the other sides are the parallel lines. So they're congruent by alternate interior angles. All right, now next, what else can I tell is true by just looking at the picture? Well, obviously, we got this shared side right here. AC is congruent to AC. Reflexive property. And then last but certainly not least, we can say that these triangles are congruent. So remember, what I want to prove is always my last statement. Now, what information do I have? I have a side, an angle, and a side. So it's going to be SAS, side, angle, side. Whew, nice. All right, and then the last proof of Unit 4. And then once we're done with Unit 4, we are 99% done with proofs. All right, so we got right angles. All right, it's also telling us that's congruent to that. So we're going to be a little bit lazy and just write given. All right, and then we know that these angles are congruent, D and G, and then this angle is P and G, by right angle congruence theorem. So sometimes it specifically makes you say right angle congruence theorem. Maybe it might say definition of right triangle. Nonetheless, right angles are important. Why? Because we also, again, have a shared side, GN. GN is congruent to GN. Reflexive property. All right, so what do we got going on right here? We got right triangles. The shared side was a leg. This was the hypotenuse of the right triangle. So I can say that the triangles are congruent, so we're going to be lazy and just put an arrow right there, by HL. And we are done. Hooray. Smell you guys.